Hello everyone, I am Atharv Chauhan and welcome to our video. In this video, we'll cover a section D of internal test 3. It's gonna be a short video because we don't have much questions in this section. The questions in section D are based on assertion and reason type questions. This section checks not just whether you know a concept but whether you understand why it works. So let's see how it works now. In every question, we get two statements: assertion A, a fact or a claim; reason R, an explanation related to the assertion. Our job is to check are both statements true, and if they are, does the reason actually explain the assertion? All the questions in this section ended up having the same answer, option A, meaning both are true and reason explains the assertion. So let's start with question number 30. Question number 30, based on big data and distributed processing, the assertion tells us big data needs distributed processing, and reason implies because it cannot fit into one machine's memory. And yes, both are true, and the reason perfectly explains the assertion. Here's why: big data is huge, often terabytes or petabytes. A single machine simply cannot store or process that much information. So, we split data across many machines and process it in parallel. That's exactly what distributed processing means. Question number 31. Based on KNN and LSH optimization. Assertion is KNN optimizes with LSH. Reason, it speeds up search by avoiding exact neighbors. Again, both are true and the reason directly explains the assertion. Simple explanation is KNN becomes a slow when data has many features. Locality sensitive hashing LSH helps by grouping similar points into buckets so KNN doesn't have to check every single point. This means KNN becomes faster by using approximate neighbors instead of exact ones. Question number 32 now, based on ensemble learning and wisdom of crowds. So assertion: ensembles use the wisdom of crowds, and reason, they combine multiple models. And yes, again, both are correct, and the reason explains the assertion. Why? When we continue multiple models like random forest or as XGBoost, each model contributes its own perspective. Together, they produce a more accurate and stable prediction, just like how a group's collective judgment is often better than a single person. That's the wisdom of crowds applied to machine learning. Towards our last question of section D, based on Python DQ. Assertion is Python DQ generalizes stacks and queues. Reason, because it supports adding and removing from both ends. This is also true, and the reason explains the assertion. The quick explanation here is a Python DQ from collections is super flexible. You can push pop from the left or right in O1 time. That means you can behave like a stack, LIFO, or a queue based on FIFO. So yes, DQ is like a parent structure for both. Talking about the key takeaways from this section, to wrap up, big data implies needs distributed processing because it doesn't fit on one machine. KNN becomes faster with LSH, which uses approximate neighbors. Ensembles are powerful because combining models is like using a group collective wisdom. And DQ is flexible and works like both queues and stacks. All the question in this section had option A as the answer, meaning every reason clearly explained its assertion. So yeah, this is for our video. We have covered each question of section D. Thank you for watching this video. Thank you for listening. I hope that this video